Dear students, in this session we will further investigate the implications of fiscal multipliers in a three-sector model. In the previous class, we have considered balanced budget multiplier, also known as unit multiplier or Havelmo theorem. Now we investigate further each type of fiscal multipliers separately. And our starting point is the income determination model in a three-sector economy, as we have just described in the last class. That is, we start with an economy consisting of households, business firms, and government. And the condition for equilibrium is y is equal to C plus I plus G. Aggregate supply is equal to aggregate demand. C plus I plus G. And C is equal to A plus B y minus T. Consumption depends on disposable income. Remember the assumptions we have considered in the context of three-sector model. I is assumed to be exogenous, G is also assumed to be exogenous, T is also assumed to be exogenous constants. Now, we start with a model in which government collects an amount equal to T bar and spends an amount equal to G bar. Now let us see how we determine equilibrium graphically and then mathematically. The 45-degree line, C is equal to A plus B y minus T. So now the consumption function is A plus B y minus T with the intercept A minus BT. A minus BT. We start with a three-sector model where consumption is a function of disposable income, C plus I plus G y. And with this we add the investment I, then you will get C plus I, C plus I. With that we add G equal to a particular amount C plus I plus G. Now equilibrium occurs at a level of income Y0 where aggregate spending schedule C plus I plus G intersects the 45-degree line. The 45-degree line. Now, in terms of the saving income equality, this is say I and this is say I plus G. I plus G. And I plus G is equal to S plus T in terms of saving income equality. Now remember this. Now S function has the intercept. As we have derived earlier, S function has the intercept as minus A minus 1 minus bt and S plus T has the intercept that also we have derived in the last class, minus of A minus bt. So when government collects an amount equal to T bar and a government G is equal to G bar, the consumption function shifts downwards as A minus bt from A. Saving function also shifts downwards from minus A to minus A minus 1 minus bt. Adding this, you have S plus T is equal to I plus G at a level of income equal to Y0 in terms of saving income equality. Now, suppose that, so this is I, this is G, initial level of government expenditure. Now we assume that government increases expenditure on goods and services by an amount equal to delta G. So we have a new spending schedule, C plus I plus G plus delta G, and this is delta G, C plus I plus G plus delta G. Now, what happens is equilibrium level of income increases from Y0 to Y1. Equilibrium level of income increases from Y0 to Y1. Y0 to Y1. And in terms of saving income equality, this is shown as I plus G plus delta G occurs here equal to S plus T at a level of income Y1. So government expenditure, government purchases of goods and services increases. What happens is equilibrium level of income increases from Y0 to Y1. Now, if we wish to compare with the graph which we have considered earlier, the level of equilibrium in that graph was Y0 initially with only an increase in G with T equal to 0. Y1 with both T and G equal, balanced budget. Now, this is the equilibrium with the government T and G with the increase in expenditure, government purchases only. Now, given this information, we can calculate government expenditure multiplier like this. Y is equal to C plus I plus G, and this is equal to A plus B Y minus T plus I plus G. Solving, Y is equal to 1 by 1 minus B into A plus I plus G minus Bt that we have considered earlier. And delta Y is equal to 1 by 1 minus B into delta G, or delta Y by delta G is equal to 1 by 1 minus B. And this is the government expenditure multiplier, delta Y by delta G, 1 by 1 minus B. And as we have discussed earlier, the value of the multiplier resulting from an autonomous change in consumption expenditure, resulting from an autonomous change in investment expenditure, autonomous government expenditure, all these multipliers are identical. But the impact of tax multiplier is different. It is b by 1 minus b. The value of the multiplier is 1 less than the value of any of these multipliers. Not only that, it is opposite in sign. So this is the government expenditure multiplier. Now let us consider a second type of fiscal policy. Suppose that government changes its tax from T plus delta T. Government changes its tax from T to T plus delta T. An increase in tax, keeping constant government expenditure. Now let us see what will be the corresponding change in income. As usual, the 45-degree line, 45-degree line. Now, the consumption function, when government increases its tax, keeping constant G, Y actually decreases. Let us see how. Initially, the equilibrium level of income is established at C is equal to A plus 1 minus A minus BT plus BY. C is equal to A minus BT plus BY, and this is A minus BT. C. And let it be C is equal to A minus BT plus BY, and C plus I plus G. C plus I plus G is given, and the equilibrium is determined here at Y0. C plus I plus G. Equilibrium level of income is determined at C plus I plus G, and the equilibrium level of income is Y0. C is equal to A minus BT plus BY. Then added to this is C plus I plus G. Now, in terms of saving investment equality, this can be given as I plus G, I plus G is equal to S plus T. S plus T. This is S plus T. I plus G is equal to S plus T with the intercept of S plus T, as we have derived earlier, is minus of A minus BT. S plus T. Now we assume that government increases tax from T to T plus delta T. Now, as a result, what happens to the consumption function? The consumption function, now C is equal to A plus B, Y minus T, C is equal to a plus b into y minus as we have seen t plus delta t is equal to a plus by b y minus t minus delta t. So the new consumption function is a plus b minus bt minus b into delta t. You first remove these brackets, then multiply this. So a plus b into y minus bt minus b into delta t. So this can be written as a minus bt minus b into delta t plus by. Now the consumption function becomes a minus bt minus b delta t plus by. So consumption function shifts downwards like this. The new consumption function c dash with the intercept a minus bt is equal to a minus bt minus b into delta t plus by. And as you can see, minus b into delta t is the distance. This distance is minus b into delta t. The distance is minus b into delta t. The intercept is now a minus bt minus b into delta t. So as a result of the shift in consumption function downwards, aggregate spending function also shift downwards as c dash plus I plus g. So the new equilibrium level of income is y1. The new equilibrium level of income is y1. And as we have shown earlier, in terms of this is s dash plus t, saving function also shift downwards, and as tax increases s dash plus t shifts upwards, and this distance is b into delta t, So there is the new equilibrium I plus g is equal to s dash plus t occurs at new level of income y1. So change in tax affects aggregate demand, as you can see, only through its influence on the consumption schedule or the saving schedule. As tax increases, only a part of the increase in tax is translated as reduction in consumption. The rest is absorbed as a reduction in savings. So consumption schedule shift downwards, not by the full amount of tax, only b into delta t. The other part is a shift down of the saving function. The saving function also shift down, because the effect of an increase in tax on consumption is not direct. Now this can be explained like this. In mathematical terms, equilibrium level of income is 1 by 1 minus b into a plus I plus g minus b into t, a plus I plus g minus bt, and delta y is equal to minus b by 1 minus b into delta t minus b by 1 minus b into delta y, or delta y by delta t is equal to minus of b by 1 minus b. And this is the tax multiplier. The tax multiplier. So the value of the tax multiplier is b by 1 minus b, and an increase in tax always reduces income, and the impact depends on the value of b. If b is greater than 0.5, delta y less than delta t. If b is equal to 0.5, delta y is equal to delta t. Delta y is equal to delta t. If b is less than 0.5, delta y is greater than delta t. That is, the effect of an increase in tax on income depends on the value of b. b greater than y, reduction in y is greater than reduction in tax, increase in tax. Reduction in income is equal to increase in tax. Reduction in income is less than increase in tax. So this is the tax multiplier minus b by 1 minus b, and tax multiplier is always lower than government expenditure multiplier. But remember this, balanced budget multiplier is a situation in which initially the budget is balanced such that T and G increases by equal amount. Then we have delta y. Increase in y is equal to increase in G is equal to increase in T. Remember these points. Provided that the budget is balanced, increase in income is equal to change in the size of the budget. Increase in the size of the budget. This is balanced budget multiplier. And when we compare delta y by delta g plus delta y by delta t, you have the value equal to 1. That is, government expenditure multiplier is always 1 more than tax multiplier. So it is known as unit multiplier theorem.